Hi students, a very pleasant and warm greetings to you all. Hope you are doing good. Last session we have seen about e-commerce threats, right? Last session we have seen about information leakage, tampering, payment frauds, malicious code threats, distributor denial of service attacks, cyber squatting, typo piracy and all we have seen, right? In this session, we are going to see about dimensions in e-commerce security, right? As the security issue is the most worrying issue for this e-business, ensuring the security of e-commerce activities has become the core research field of e-commerce, right? We are having some of the security elements involved in this e-commerce, right? Here we are going to see the dimensions of e-commerce security. Okay, here the security is the main issue here in this e-commerce, right? Let's see what are the security elements involved in this e-commerce, right? Authenticity, availability, completeness, confidentiality, effectiveness, integrity, non-repudiation, privacy, reliability, reviewability. These are the elements involved in e-commerce, right? Let's see them in detail. First one is authenticity. Authenticity is confirming whether that is the genuine one. That is authenticity, right? Here we are confirming the genuineness of the data which is shared in a particular website or in a particular page, right? That is authenticity. Next one is availability. Availability means prevention against data removal or the data delay. If some data will not be there, it won't be available there, right? That is availability. The next one is completeness, unification of all business information. That means complete everything, all the business information must be there. That is completeness. And the next one is confidentiality. That is protecting the data against unauthorized disclosure. If you are giving a data or if a data is there in a page, that must be confidential. If you are paying the amount to that website, the payment details must be confidential, right? So that if some unauthorized person or unauthorized account gets linked with this, that data won't be shared with them, right? That is confidentiality. And the next one is effectiveness. Effective handling of hardware, software, and data. That is, uh, software will be there, right? Programming will be there, hardware will be there, and the data. Everything must be handled effectively, right? That is effectiveness. And the next one is integrity. That is prevention of the data being unaltered or being modified. Integrity means the genuineness only. It is the data which is there should not be changed, right? The prevention of the data being unaltered or modified. That is integrity. And next one is non-repudiation. That is prevention against violation or agreement after the deal, right? Prevention against the violation agreement after the deal. Non-repudiation means it will have a deal or it will have an agreement of time. That time or that rules must not be violated. That should not be changed, right? That is non-repudiation. Prevention against violation of the agreement after the deal. And the next one is privacy, that we all know. Prevention of customers' personal details being used by others. Privacy, our details must be private, right? So our details should not be shared with anyone else. That is privacy. Prevention of the details or the personal details of the customers should not be shared with the third person, right? That is privacy. And the next one is reliability, that is providing a reliable identification of the individuals or business. That is reliability. It must be a real one. We have to give the real identification of the individual, or if you are for a business means for that business you have to give the identification of that business, right? Reviewability, that is capability of monitoring activities to audit and track the operations. Here, reviewability. Here we'll be having the ability to monitor the activities, to audit, and you can just track the operations also. Okay, if you are ordering a product, you can just track the product, where the product is, at which time it will reach you. That is tracking, right? We have seen about the dimensions of e-commerce security, right? So we have seen here about authenticity, availability, completeness, confidentiality, effectiveness, integrity, non-repudiation, privacy, reliability, and reviewability, right? Next, we are going to see about security technologies in this e-commerce transaction. Okay, here this is a large amount of confidential information will be there, right, in this e-commerce activity. So this must be transmitted through a safe and secure network only. Some sophisticated security technologies are needed to ensure the security of e-commerce transactions, right? At present, if you see the security technologies in this e-commerce can be classified into encryption technology, authentication technology, and authentication protocols, right? Let's see what is encryption technology first, right? Here, security technologies in this e-commerce transactions include encryption technology, authentication technology, and authentication protocols, right? Here, encryption technology, this is a effective information security protection. This is defined as converting a plain text into a ciphertext. You know what is encryption. I have said you already, right? Encryption means you are converting a plain text into a meaningless ciphertext using encryption algorithm. In this way, you will be able to ensure the confidentiality of the data, right? The encryption or this decryption will use a key to encrypt or decrypt the data, right? Here at present, if you see two encryption technologies are used, they are symmetric key encryption system and asymmetric key encryption system, right? We'll see about this symmetric key encryption system and asymmetric key encryption system here. Before that, you just recall the encryption process once more. Encryption means that is the effective information security protection. That means if you are having a message, if you are having a plain text, you will be changing it into a meaningless ciphertext using this encryption algorithm, and then the confidentiality of the data will be carried out, right? Decryption means you are changing the ciphertext into the plain text again, back. That is decryption, right? To encrypt or decrypt, we'll have some technologies, right? Here at present, if you see, we have two encryption technologies. One is symmetric key encryption system and the other one is asymmetric key encryption systems. Let's see what is symmetric key encryption first, right? The data encryption standards, that is DES. This is the symmetric key data encryption method. Okay, this was introduced in America in the year 1976, right, by Federal Information Processing Standard, that is FIPS, right? This symmetric key data encryption, this method was introduced in America in 1976 by FIPS, that is Federal Information Processing Standards, right? This DES, that is Data Encryption Standard, this is the typical block algorithm that takes a string of bits of plain text with a fixed length, and throughout the series of the complicated operations, it will transform it into the another encrypted text of the same length first. This data encryption standards will have a key to customize the transformation. So what will happen means, in this theory, the algorithm can only be deciphered, that is, it can be changed, that is decrypted by the people who know the exact key that is used for this encryption, right? This data encryption standard key, this is apparently of 64 bits, but in fact the algorithm will use only 56 there. The other 8 bits are used for verifying the uh, parity and then it is deleted, right? Here the DES, this is the typical block algorithm. This will take the bits as the plain text or the clear text, and it will have a length, right? That length will be converted or encrypted to, it will be changed to an encrypted text of the same length first. It has a complicated process of transforming this plain text to ciphertext, and this will happen. And what here 64 bits are there, right? This DES key is of 64 bits, but this algorithm will use only the 56 bits, and the other 8 bits will be used for verifying, and then after verifying the parity, it will be deleted, right? Today it is considered that this data encryption standard is not safe for many applications, mainly because of this relatively smaller key size. It has only 56 bit key size, right? So because of this smaller key size, this DES is considered not a safe one, right? So this is about symmetric key encryption. Let's see what is asymmetric key encryption. Okay, asymmetric key encryption means that is a public key encryption. Okay, asymmetric encryption means we'll say it is RSA algorithm. Okay, that is reversed Shamir-Adleman algorithm. This uses public key authentication and digital signatures also. Right? Till 1970s and all, if you see, there are only the symmetric crypto systems and all. Here the transmitter and the receiver will have the same key. This had a small problem that in exchanging of the key and managing of the key. Not like here in this asymmetric key system, it is not like symmetric key. The communication of these parties need not know others' private key in this asymmetric key encryption, right? Here each user generates their own pair of key, and it will consist of a private key and a public key. The public key encryption method is the method of converting the plain text with the public key to a ciphertext from which the plain text is retrieved with a private key. Right here in this asymmetric key, if you say in a simple words, I'll say it will have a public key and private key. Private key will be only with the user. Public key will be there in both the sides, right? Public key encryption will be done while converting the plain text with the public key. They will be converting the plain text to ciphertext, right? From which the plain text can be taken with the retrieved from with the private key. Right, understood? Here symmetric key means there only 56-bit key is there, and there only one key is there. Here asymmetric key, it is a public key encryption. Right, here we'll have a public key and private key also. Private key means it can be used only by the user. Only the user will generate that pair of key. Right, that's all about this symmetric key and asymmetric key or public key encryption, right? So you know what is encryption technology and symmetric key encryption and asymmetric key encryption, right? Let's see the difference between this symmetric key encryption and asymmetric key encryption. In symmetric key encryption, same key will be used for both encryption and decryption process, right? In asymmetric key, you know, different keys will be used. For encryption, we'll use one key, and for decryption, we'll use another key. In symmetric key, the speed of the encryption or the decryption is very fast, right? In asymmetric key, when compared with the symmetric key encryption, the speed of the asymmetric key encryption or decryption is slow, right? In symmetric key encryption, the ciphertext and this plain text are of same size, right? Here in asymmetric key encryption, the size of the ciphertext is always greater than that of the plain text, okay? So, in symmetric key, plain text and ciphertext of same size. In asymmetric key, the size of the ciphertext is always greater than that of the plain text. Okay, the next point is in symmetric key, algorithms like DES, AES, RC4, these and all uses the symmetric key encryption. Here in asymmetric key encryption, algorithms like RSA, ECC, DSA, these and all use asymmetric key encryption, right? This symmetric key encryption provides the confidentiality But this asymmetric key encryption provides not only the confidentiality, it will produce the authenticity and non-repudiation also, right? In the symmetric key, the number of keys used grows exponentially with the number of users. Here in this asymmetric key, the number of keys used grows linearly with the number of users, right? That is the difference between symmetric key and asymmetric key encryption. In symmetric key, we have same key for both encryption and decryption. Here in asymmetric key, we have different keys for encryption and decryption. The speed will be fast in this asymmetric key, and comparing to this symmetric key, symmetric key, the speed will be fast, and in this asymmetric key, when compared with symmetric key, asymmetric key will be slow, right? And the plain text and ciphertext will be of same size in symmetric key. The ciphertext will be larger in asymmetric key encryption, right? And it provides the confidentiality. This symmetric key provides confidentiality, asymmetric key provides confidentiality, authenticity, and non-repudiation also. Algorithms, if you see here in symmetric key encryption, DES, AES, RC4, this and all uses this symmetric key encryption. And in asymmetric key, if you see RSA, ECC, DSA, these all use asymmetric key encryption, right? The number of key used also grows exponentially with the number of users in the symmetric key. Here in asymmetric key, it grows linearly with the number of users, right? This is about symmetric key encryption and asymmetric key encryption, right? Next, we are going to see about authentication technology. Here we are seeing about security technologies in e-commerce transaction, right? Here we saw encryption technology, authentication technology, and authentication protocols, right? So here we have seen about encryption technology. Inside encryption technology, we had symmetric key encryption and asymmetric key encryption, right? Now we are going to see about authentication technology, right? Here authentication technology means the main role of the security certification is to ensure the authentication, right? And not only the authentication, we have to ensure the integrity and non-repudiation also. This can be achieved through digital signatures and digital certificates only, right? Let's see what is digital signature and digital certificates first, right? Digital certificate. Digital certificate means it is known as public key certificate, right? This is a electronic document which is used to prove the ownership of the public key. This certificate will include the information about the sender's identity, and it will have a digital signature and a public key, right? Digital certificate. From the word itself, you can say it is a electronic document. Okay, this is used to prove the ownership, whether that person is the owner. Like that, it will have a public key. This certificate will include the sender's identity, and it will have a digital, that is electronically signed one, and then a public key, right? Digital certificate function. This is similar to the function of identity cards and all. Identification cards like passports, driving license and all, right? This digital certificate has the same function of this identity cards, right? Digital certificates are issued by recognized CA, that is certification authorities only. When someone requests for a digital certificate, the authority verifies the identity of the requester, of that person. The authority will check for the identity of that person, and if the requester fulfills all the requirements, the authority will issue the digital certificate, right? When the sender uses a certificate to sign a document digitally, receiver can trust the digital signature because he trusts the certification authority, right? So we can just verify it if you need, right? Has done their part verifying the sender's identity, right? So here digital certification, this is a process of signing or it is a process of getting the identity correctly, right? This digital certification are given by a recognized certification authorities. If you need a digital certificate, you have to request to the certification authorities, and they'll check your identity, and if you are okay, if your identity is good and if all the requirements are fulfilled, then they'll give you the digital certificate, right? If digital certification is done, to sign the digital document digitally, the receiver can trust the digital signature, because it will be trusting the certification authorities, right? So the sender's identity is true, right? Common digital certification systems are X.509 and PGP, right? PGP is nothing but pretty good privacy, right? Pretty good privacy. This is Phil Zimmerman developed this PGP, that is pretty good privacy, in the year 1991, right? In the year 1991, this Phil Zimmerman, he developed this PGP. Okay, this is a decentralized encryption program that provides the cryptographic privacy and authentication for data communication, right? This provides the cryptographic privacy. Cryptography means it is the process of encryption or decryption, right? Cryptographic privacy and authentication for data communication. This PGP encryption will use a serial combination of hashing, data compression, symmetric key cryptography, and asymmetric key cryptography, right? And it works on the concept of web of trust, right? That is PGP, right? It works on a combination of hashing, data compression, symmetric key cryptography, asymmetric key cryptography, and it works on the concept of web of trust, right? And the next one is X.509. That system is a centralized system in which the authenticity of the key is guaranteed by the hierarchy of certification authorities, formally certifying the key relationship with the identity of its owner, right? Due to its clear responsibility, it will be easier to implement in the law. X.509 is currently worldwide accepted certification technology, right? This X.509. This system is a centralized system, right? Here, the authenticity of the key is guaranteed by the hierarchy of the certification authority. They will be formally certifying them with the key relationship, and they'll be having the identity of the owners. So here, the responsibility is clear, right? So the implementation of the law also will be easier. And so this X.509, this is currently accepted worldwide for the certification technology, right? So today we have seen about digital certificates in this authentication technology. We'll see about this digital signature in the next session, right? So today we have learned about encryption technology. In encryption technology, we have seen about symmetric key encryption and asymmetric key encryption, right? Tomorrow we'll see about digital signature, right? Thank you for your valuable time. Stay home, stay safe, take care, bye.